So let's do several factoring techniques. And in the previous video, there was things that where you had to maybe pull out a greatest common factor, all that kind of stuff. And if I look at number 1, I could factor out a 5 first. For this problem, I think I'll save it till the end. So let's just see what happens if I don't. But either way would get me where I needed to be. So I look at this and I count 1, 2, 3, 4 terms. And when I see 4 terms, that has me thinking about grouping. So hopefully this works out as a nice grouping problem. This has a 5. I can factor 5 out from 15. This has x cubed, but I'm limited to factoring out x squared from the 1 that's to the right. So here I am factoring out 5x squared, which leaves me with x plus 3. And I can distribute that in my head to check that it's right. On the other side, I can pull 5 out, which would leave me with x plus 3. So that my two sides match up, I got x plus 3 in both of them. So I can factor out 5x squared minus 5 and write it as that times x plus 3. Now, I'm not done factoring. Now I think I would like to deal with this 5. So I'm going to factor the 5 out to the left, which will leave me with x squared minus 1 times x plus 3. And now I recognize x squared minus 1 as a perfect square. So I'll write 5 times x plus 1 times x minus 1 times x plus 3. And then I look through this and I'm like, well, if I'm applying several factoring techniques, and now I'm getting closer to the end of the chapter, I scan through it and I don't think you can pull anything else out of there, so we'd be done. Now, this will be very brief, my next point I make about this first problem. Originally, I could have factored out 5 from everything, and that's totally cool. But then sometimes maybe you'd want to go do this off to the side and bring the results back in. And the reason I point that out is because at this point, I'd probably like to see this as brackets, because it helps me then factor out x squared from the 2 terms on the left minus the 5 that I would have accidentally rewritten actually. And then I'd have to factor out a negative and then have x plus 3 here. That's totally fine. It's just sometimes people maybe don't like dealing with that 5 hanging outside that whole time. And then now my brackets have lost their meaning, and I can write that as x plus 1, x minus 1, x plus 3. So yeah, like I said, this was something I did growing up. Growing up as a math student, apparently, as my own personal strategy to not lose my place in doing things like that. It's nice to do brackets on the outermost parts to help it be a little bit more clear. Okay, write down number 2. You can try that on your own as well and see if it goes smoothly. Go ahead and pause the video and get caught up so that I can talk about this next one quickly. On the left, I can factor out x squared. On the right, I can factor out 25. And that's going to be minus 25, which will end up changing the sign over here. Then I can recognize that they have like terms and put x squared minus 25 on the left. The right part is totally factored, but the left part is a perfect square. I scan through the entire problem. Maybe if it bothers me, I rewrite this to the left because there's a number in front of the x as opposed to in the other parts. But really there's no problem just boxing that as it is. Cross out problem 3 and then rewrite this instead, because you can't do problem 3 unless you use factoring techniques that you don't find out about until later. So through grouping, we got 6x cubed plus 30x squared on the left, and of those terms I can factor out. Actually, pause this video and make this an OYO problem. I'm just going to put all the answers on there. In just 3, 2, 1. I'll leave this up for a few seconds for you to check and briefly talk about it. The greatest common factor of these terms was 6x squared, 24 on the right. Good feeling when x plus 5 showed up, because then you could just take 6x squared minus 24 and factor that out. Moving to the next step, you realize maybe you can take a 6 out, leaving you with x squared minus 4, which is a perfect square of x plus 2 times x minus 2. Now your route to get to this final endpoint doesn't have to be the exact same as mine, but the end result for total accuracy does. This is the last of the two videos for factoring differences of squares, so hopefully now you feel like you have a bunch of tools to pull from for how to do these problems and are still able to balance all the different types of problems, including grouping, difference of squares, all that stuff. And again, difference means subtraction. Squares means you have values that are squared, and so it's the difference of squared values. One last tip, not even a tip actually, this shouldn't have said binomial, polynomial. Even though that's in red, maybe make that small change.